Well, I see a big crowd. Thank you very much. Oh gosh. See. All right, can someone give maybe a thumbs up or a yes in the chat or something that they can see what I'm looking at? Yes, thank you, Gulnar. Great, so thanks very much for being here and being interested. I'm excited to have a chance to share a little bit about what we've been working on as part of our ATE grants at St. Paul College. And let's see, I guess I'll just dive in. So to start off with, I want to give you a little bit of background so you can kind of get context for what our programs are like at St. Paul College and set the stage for what our research questions are. So St. Paul College is located in beautiful St. Paul, Minnesota, and we are an urban community college, community and technical college, and we have the potential to recruit students traditionally underrepresented in STEM, many first generation students, many students of color, and also many Pell eligible students, which is a proxy we often use for low income. Also, just, I'm sure many of you know this, but many science students do at least some coursework at two-year schools. The most recent numbers look at say it's around 50%, but most education research is still coming out of four-year schools. That kind of can become a problem if you're making decisions at our community and technical colleges based on a population of students at the universities if we haven't expanded and confirmed those findings in our population. So I think that's part of our mission at community and technical colleges for those that are doing research in biology education or education research to keep expanding on those findings, as well as, of course, encouraging more underrepresented minorities to pursue scientific careers. In addition, our grant and our college is interested in expanding and growing our smallest science program, which is called Science and Engineering Technology. And we want to be smart about designing marketing strategies and thinking about how to recruit students into this program. So I am not going to watch this video right now. I realized I had a little bit less time than I initially thought. So this is a video that just tells us a little bit more about our science and engineering technology. It's about 3 or 4 minutes. So I'm just going to summarize it for you. And I can maybe put this into the chat later, or you can watch it later. But we have 4 main science programs at our college. And they are what I think of as traditional transfer pathway programs that includes chemistry, biology, and engineering. That the idea is a student takes these and then transfers and gets their BS at a 4-year institution. And then we have our science and engineering technology degree, which can lead to a transfer degree where you go on and go to a 4-year institution, but is also supposed to allow students to go right into employment in a scientific field. There is interplay between these because students can actually stack their majors, so they can fairly easily get both a biology transfer pathway and a science and engineering technology degree together. So now they have multiple credentials. But in our science classes, we have another population of students that aren't majoring in biology, and these are the pre-health students, right? So our students we have students that are pre-nursing and pre-pharmacy and pre-others as well. And those students are interested in professional programs for the most part, and then to get employment. So that's the understanding we have if you just look at our programs on our program guide sheets, but it's a little bit incomplete. So part of our question is to better understand what our STEM students are thinking. What are the career goals of the students in our STEM classes? In particular, we're focusing on General Chemistry 1, since it's taken by both science and non-science students, as well as some upper division or upper level classes that we'll talk about. So that's our first question that we're trying to investigate. Our second is what are the students' attitudes about their identity as scientists, their self-efficacy, which would be their perceived skills that they have in science, how good they think they are at doing science, and then intrinsic motivation being how motivated they are to do well in their science classes. And do we see correlations between those attitudes and their career goals? And then our third question, I've got the numbers off, but the third question, not the fifth question, is do demographics or curriculum changes or additional science courses shift those goals and attitudes at all? So let's look at some data. That's my favorite part. Oops, I maybe should tell you how we did it first, and then we'll look at the data. So we created a survey using some existing published surveys that have been used at other colleges. And we chose sections from the surveys that were most relevant to our questions in our community colleges. So for example, we took the entire science identity section from the Chambers paper and asked those sets of questions and gave the survey in general chemistry. We've been doing this for several years, so we have several hundred responses by now. And then starting last spring, we've also given the same survey to second-year science students. These are genetics and organic chemistry 1 and 2 students. We did not use any students under 18 or anyone who did not consent, and then we linked the responses to the student records. We have been doing some small literature-informed curriculum changes, haven't done a lot of analysis on how well that's worked. It's been COVID kind of threw things off a little bit in there. And then we've been doing the analysis. We've done validity, reliability checks through factor analysis in Cronbach's alpha, and then used statistical methods in R, mostly generalized linear models, GLMs, which if you're a statistician, you can probably tell me more about how those work than I can, but that's the type of statistical method we mostly used. So let's look at the data. So the first question that we asked was, what are the STEM student career goals? The data I'm showing on this page is from the General Chemistry 1 students. And let me walk through, this is a busy graph, so let's walk through this a little bit. So the different colored bars are the different career goals. And we've split them by male identifying and female identifying students. So the top groups of graphs are the males, bottom groups of graphs are females, and then you can see the races on the left. What I first want you to notice is that the bright green bar is health or medical professional, and it dominates the color. Most of our students are not choosing to go into, or at least they do not choose a scientific career goal as their goal. The next thing to notice is that the olive green, and I guess I'll call it a tangerine color, is highest, at least relatively highest, in the white males. If you compare to white males, that's the highest bar, to the black males, you right away see a very significant difference. Also, if you compare white females to black females, you see a significant difference. And then finally, if you compare males in general to females in general, you see there's a lot more olive and tangerine in the male than in the female. And that is significant, significant results. So students identifying as black or female are highly more significant, I should say, that was poorly worded, but are much more likely to select a health or medical career, and conversely, less likely to pick science and engineering. We also saw a similar trend, although it wasn't quite as striking, with Hispanic students as well. A surprise that kind of came out from our data is that Pell students, low income, were actually less likely to select health and medical, a little bit more likely to select science. We did not see a significant difference in first generation, part-time students, or in the second year courses versus first year courses. So that sort of answers our first question. Like, mostly medical and health is what we see, but we do see, of the ones that are choosing science, a significantly lower number of female and Black students and Hispanic students choosing to go a science career. So I guess the question then is why? What are the reasons that they're choosing science? So one of the things that we think about when we teach science is, well, maybe it's because they're not engaged with science, right? They don't identify with the science itself. So we asked, what is their identity? What is their self-efficacy? And what is their intrinsic motivation? And do they influence the career goals? So just overall, I think it's interesting to see what the numbers are. So self-efficacy, the average was a little bit over 3 out of a 5-point scale on how students felt, how good students felt they were at science. Science identity was fairly low. It was under 3. So on a 5-point scale, that's reasonably low. So we don't have a strong student identity with science. And intrinsic motivation was quite high at almost 4 out of 5. We expected that maybe we'd see students that select science and engineering as a career goal would also have higher science identity, higher science self-efficacy, and maybe higher motivation in their science classes. And I think what you should see in this graph is that is not the case. There's no correlation between career goal and higher science identity, for example. We in fact see about the same level across any of the career goals that we picked. So it does suggest that it's not about their identity with the science or their abilities, their self-assessed abilities, their self-efficacy in science. So I guess the next question that sort of leads to is then what is influencing their career goals? So we looked a little bit more, dove into the science identity and self-efficacy and intrinsic motivation a little bit more. And we actually found that the Asian students had significantly lower intrinsic motivation and self-efficacy. And surprisingly, and actually it's a fairly big difference, the science identity is higher in Black students. So if you look at the middle histogram or box plot, not histogram, box plot in the middle, on the bottom, that's the science identity. The farthest left box and whisker is the white students, and the second one over is the Black. And you can see that there's a significant difference in their identity scores between white and Black. But they are less likely, and not just less likely, much less likely to choose a career in science, even though they're identifying as scientists or with science more strongly than the white students. Male and females had no differences in their scores on any of these factors. No difference in self-efficacy, science identity, or intrinsic motivation. But once again, they are still much less likely to choose science as a career goal. One last piece of data that I want to show you before we just do a little discussion and conclusions is we also looked at comparing the second year students versus the first year students. And we are still working on increasing our numbers for the second year students, but we are starting to see some interesting trends. One is that we're seeing a little bit higher self-efficacy in second year students. It's starting to increase, and actually it's a bimodal distribution. So some of the students, that's the purple, is the upper level or the upper division. It's not really upper division for a university person. It's a second year level class. We see a population that now has higher self-efficacy. We also see a little bit of a shift in the science identity starting to go up a little bit in second year students versus first year students. And the motivation seems pretty strong in both populations of students. Again, these are trends. We have not seen we don't see a significant p-value yet, likely due to the lower N in our upper level survey respondents at this point. So what can we conclude so far from our work on this ATE project? One is that female identifying students and Black students are much less likely to choose scientific career goals. Second, does not seem to be due to self-efficacy, science identity, or intrinsic motivation. I shouldn't say due to. It doesn't seem to correlate with self-efficacy, science identity, or intrinsic motivation, at least at our college. This was surprising because at the universities where they've done these surveys before, they did see a correlation with science careers and higher self-efficacy and science identity. This also kind of makes me think differently about how to help recruit or convince maybe even students to go into science. And it might not be about engaging students with science. I mean, that's maybe still important, I think, but that's just because a student's like, this is cool, this is interesting, I'm good at this, doesn't mean they want to go and become a scientist. So what other things might be influencing career choice if it's not their identity or their self-assessed skills or their motivation? These are possibilities. Possibly they are not getting exposure to scientific career options. So health and medicine is something that they've been introduced to more. Maybe they think that they want to apply their strong science skills or their strong science identity in a healthcare setting. So that's okay. I mean, I'm not telling people they shouldn't go into healthcare. It's important as well, but that's a possibility where some students might be gravitating towards healthcare. And then also that maybe science careers don't align with the students' values of what they would like, or at least a perceived atmosphere in a science career. So what can we do next? What are we going to do about this? So we're actually starting to add some career exploration exercises to our STEM courses. I've been doing this in my genetics class now for 2 semesters, and I'm curious to see if that starts to at least change the needle a little bit. I'm amazed at how many students, when I talk to them, didn't even realize that there were jobs that they could help people, and they didn't realize you work in teams and they don't have to sit in a lab all day, and it's not just white men doing science. Like there's a lot of things that they didn't know. So it's been already interesting. We've been holding some focus groups about qualitative context. We're seeing some of the same themes coming out that we're talking about. And we do want to do some more diving into the data. I didn't get a chance to look at age. There's some grade data that could go into this. And then also we have retention data as well that we could look at. So to me, whenever I go to one of these talks, I always like to think about like, well, why does this matter to me in my college or in my classes? And I think part of this has to do with many of us work with students. And I think all of us will agree that we want students to find a good career fit. Many students at community colleges are non-traditional, and they want a career that's going to pay well and that they can get to quickly and they can see themselves in. But students are often getting very little career guidance. And I think it's important for us to embed more discussion about how and why of careers in our courses, not necessarily to tell students that they shouldn't do what they're doing, but to give students a chance and the space to think about why they're doing what they want to do, and to at least let them consider the other options that they might have. And then also, I think it's important for us to advocate and talk about the career services that hopefully exist at our colleges to our students. Thank you for listening, and I hope you found some of that interesting. I think I see some stuff in the chat, so we can see what those are. And then I put my email here if you would like to contact me or ask me more questions and have further discussion beyond what we might have time for this afternoon. And again, thanks for your flexibility with me as I had to kind of scurry over here from my lab. So thanks very much. I'll stop sharing my screen and let Sandy take over next.
Well, thanks, Kristen. That was great. And for somebody who had to scurry and discuss quickly, fantastic. And now I've learned that I will make absolutely sure that everybody knows what time zone we're in with the future talks. So I'm learning some things too. And both of these are wonderful. So I'm going to go through some of the questions in the chat. And the first question, I think maybe both of you might answer, which is from Elizabeth Stewart, which she asked if there's any suggestion that COVID has increased student interest in biotech.
I'm not sure if we've actually looked at that, so I can't really answer that question, but I think it's something that they're dealing with every day. When I visited Galileo High School, right at the door, they had a testing station that was available to the students and even their parents when they drop them off. And so I feel like this is something, and the school provides free kits for them. And so I thought, well, why don't we talk about this? And like, how does this kit work? It's actually an ELISA procedure. So if we're talking about ELISA and we could put it in, and maybe they can go home and show up to their parents so they know how the kit works.
Kristen, what do you think? Oh, you're muted.
In terms of COVID, you mean? In terms of COVID influencing biotech careers? I think that they are receptive to it, maybe more than they were. It's hard to say because I don't think I did a great job pre-COVID, because pre-COVID was almost pre-survey, us thinking a lot more about community and why they go into careers. So now that I'm talking to students, they're like, oh, I didn't know you could do that. And it's also a great way. I do think it's a great way to show how science can be beneficial to the world and be to their communities. And I think that's a selling point for biotech careers is right now is because they can see direct applications of it in the world. So I think that would be something, but I haven't measured that or seen a marked increase in biotech interests or in necessarily even our program. We're seeing an increase, but I think part of it is people coming back to campus, not just an increase in interests.
Okay, Andrea Denman asked, and this is one for you, Goli, if the training for the high school students is built into the summer internship, or is that a prerequisite that happens before?
No, there's no prerequisite. So the field trips are separate from the summer internship. Yeah, there's no prerequisite. We do something. One thing that I forgot to say is that what we're hoping to do is to reach out to the students who have attended our summer program, the ones who did really well, and we think they were interested in reaching out to them to come back next summer as our lab assistants or lab aides or teaching assistants. But no, there's no prerequisite.
Okay, and then coming on or moving down, Beth asks if before taking the survey, and this is for you, Kristen, do you think the students know enough about a science career to choose it?
I would argue in many cases, the short answer is they probably don't. So like this is supposed to be a pulse of students who are just starting science to kind of see what they're starting out with, right? And so it's possible that they don't even know. I would hope they would recognize the career at least of biologist and chemist on there, but yeah, they might have not really even thought much about it.
And how do you measure their science identity?
So I mean, it's a factor set of, and I would have to go back and check which exact survey set of questions we use, but it's about a 10 question, agree, disagree. And then we take an average of their scores on those and create like a sort of a factor score on science identity. So it's not just one question that they're asked. It's like a series of 10 questions. I could pull it up or share my link later to the survey if people are interested in the questions or the survey we're using. And thinking back to what science careers they do know, that would be an interesting follow-up question that we could ask. I think that might come out in a focus group where we could actually ask, what do you think are career titles for scientists, or just ask the students even what their awareness of them are.
No, that's really interesting. And Andrea has a comment on how Black and Brown students feel about science. Could you share that, Andrea? No, you wrote it in chat, but I think maybe you should say something.
Yeah, oftentimes when I speak to my Black and Brown students, and as a person of color myself, the motivating factor for doing a lot of the career choices that the students are making are based on wanting to help their communities or wanting to help their families. So often they are ignored, their communities are ignored. And if they're living in a low income neighborhood, oftentimes they see another city that has better resources and things that are being fixed, more opportunities. And so they go into these careers in the hope to go back to their community to help their community. So that could be part of the reason why you don't see much of a difference with the self-efficacy, self-identity, and some of the other things, is because they know about it, but they don't understand how going into those careers could actually help them go back into their communities. So I think being able to articulate how engineering career, it's like, okay, you see your streets are cracked and messed up and potholes. Well, if you go into something like civil engineering, then you could go back into your community or do city planning and other things like that, that perhaps they are not aware of those types of outcomes and pathways. But it's like, well, I know about an engineer, but I don't see how that's going to help me fix my streets or help me, make sure that my family has access to proper health care, so there are just other things perhaps to build into your survey about their motivation and why.
Oh, thanks for that. Linnea, why don't you, I know you have a couple of questions. Why don't you ask yours?
Well, I didn't want to interrupt, but I'd be interested, as part of the survey, when you ask them about science careers. So I always have this feeling that, just based on my grandchildren, that if I ask my 4-year-old or 3-year-old, especially the 4-year-old, they know what a nurse does. They have no idea what I do, kind of thing. So I kind of feel like, when are they actually aware of what a scientist does? And then I get Marvel movies, So I always feel that's part of it. And I really like the idea of thinking about why a student does this, because I realized, and I was wondering about all of you. So how many of you decided to go in science to help others? Or how many went into science? Okay, good, Elizabeth. And how many of you just went into science because you love science? And then how many of you love science and then you wanted to make everybody else love science? So that's, you went into teaching. So I think this is really interesting, because I have to admit, at the very beginning, I never thought about service to other people. I was very self-serving in that I just love science. So I think maybe I'm not the best person to recruit certain populations into science then.
Ying-Su, you've had your hand raised for a while.
Yeah, thanks a lot, Sandy. So this question is for both Goli and for Kristen. With BABEC, we have done a week-long biotech experience in the classroom where we have guest speakers come in, as well as hands-on practice. And then so we did a before and after, and we see a big increase in the way students are thinking about what science is and them doing science. I was wondering if you have also done a before and after, Goli, especially for the internship. And then with Kristen, if you're thinking about doing an after, if the students are taking, say, chemistry or biology or biotech, where they're doing a lot of hands-on science and learning about science that way, does their mind shift change, in their thinking of whether they can do it and whether or not they're wanting to go into science?
So for us, sorry, I'm going to start first. We did do a pre and after survey, but we were really bad at it. So we didn't get that many students actually replying to our surveys. I don't think we can make any conclusions from what I can see. Those few students who did answer the survey questions, I didn't really see a big difference one way or another. So I don't think we have enough information to answer that question, but we will do better next time. I learned my lesson that the surveys, you have to be on top of it. Otherwise, they're not gonna fill it up.
We've tried, that's sort of the idea of trying to survey the second year students along with the first year chemistry students, the ones that are in organic chemistry and genetics. There was not a significant difference in career choices. We did see, again, a little bit of difference in like their self-efficacy and maybe science identity. The thing that we are doing now is we have an STEM grant, and we are giving, we're going to be giving scholarships to students that are interested in like doing STEM careers. And those ones, they're going to be taking the same survey, and we'll be touching, they're going to take it several times. And I think maybe then we might see some differences. I'd love to do more before and after. I think one of my own personal thoughts is I've seen something, and maybe it was when I was writing the grant that we looked at it. And a lot of times students have pretty well solidified in their brains what they think they can and can't do by the time they're a senior in high school. So the idea that we're going to change their minds once they're in college, I don't know that necessarily, I mean, maybe there's a few that we do, but a lot of them are like, I am set on this path and I am going to do this path. And some of them don't even think they can change. They're like, I'm stuck. Even if you give me another option, this is already what I locked into doing. And I think teaching that careers have flexibility, it might be nice to tell them that they don't have to choose one and go and be only doing that one. I also think talking earlier. So these ATE projects that are doing stuff with high schools or earlier, I think are really powerful, because that's where you start telling students about what science is and what science isn't.
Yeah, I think we haven't surveyed that many students just yet, but we are seeing a more diverse interest in career choice after they explore biotech careers a little bit. Now, whether that would be true a month later, after they've looked at the website and explored it, I'm not sure, but it's seeming promising. Barbara, you had some things to add. If you'd like to unmute and turn on your video.
Here I am. Excuse me if there's any background noise, excuse me. So I'm Barbara Bielek. I'm the K-12 Program Director in Madison, Wisconsin at the BTC Institute, which is a nonprofit affiliated with Promega Corporation. And for over 20 years, we've run field trip programs for middle school and high school students, as well as been part of, done a lot of other training for both adults and students. And one of the high school programs that we work with is called the Youth Apprenticeship Program, which is an excellent high school internship program in the state of Wisconsin run by the Department of Workforce Development. So juniors and seniors in high school can get specialized training in an area of interest like biotech, and then work in that area. They get high school credit for it, they get paid for it, they get college credit for it. The work hours are, they're in the program for 2 years, it's a 900 work hour program. So these are really, really significant work experiences for students who want to explore biotechnology. So I would encourage those of you that are interested in internships and apprenticeship programs for high school students to look at Youth Apprenticeship. I gave a couple of websites. But honestly, if you just Google Youth Apprenticeship Wisconsin, you will get plenty of information on that program as well. We've also worked for over 20 years with another nonprofit called the African American Ethnic Academy to increase awareness of STEM careers for students in upper elementary and middle school. And it has to be made very explicit with students, especially at the younger ages, that health professions are also STEM professions. Because we used to do surveys. Would you like to be, we always teach them in the acronym stuff. Would you like to be a STEM professional? And what they said is, no, I want to be an anesthesiologist or something like that. So that there was kind of a disconnect between STEM and health professions. We also, no matter what our theme is, we really make an effort to showcase STEM professionals of color at all stages of careers, and also from a wide variety of careers. So everywhere from 2-year associate degree scientists to don't just have postdoc PhD people come in and talk to students. Get kids from all over, or not kids, get professionals from all over, all levels, all colors, to come in and talk to your students.
Well, that's sounding great. James has a question for Kristen. James, do you want to ask it, or do you want me to read it from chat?
Hey, I'm asking this question because I keep hearing people talking about self-efficacy and science identity, like more and more. And I didn't become familiar with those variables or terms until we started considering, we started using social cognitive career theory, SCCT, which I hadn't really heard of before either, but it was just a way of kind of like, well, how are people making decisions? What kind of things impact this? And it seemed not esoteric, but I was just like, is anyone using this theory? Are any other people using this theory? And then suddenly I started hearing more people hitting on this. So I guess I'm wondering if you pulled from SCCT, if that's something that you're familiar with, and if that, because I think the reason that we were drawn to it when we were looking at how people either consider to pursue an internship or not in bioscience was just that they were like, oh, they're validated survey, assessment tools used to kind of measure these, which I think are kind of subtle, notions of self-efficacy and intrinsic motivation. And the way that we were able to ground it was, well, there's all this research that's being done on this, and so we'll piggyback on that. But as it took, without question, all of us on our team like a good year or 2 years to like be comfortable enough with the theory to even, I don't know, there was just some way in which it was kind of awkward. So anyway, I'm just intrigued. Why is everyone talking about self-efficacy and science identity now? Like I felt like those things were absolutely embedded in this theory that I didn't think a lot of people were using yet. So I'm just wondering where you came up with those variables, why they were important.
Well, first off, this SC, the social cognitive career theory, I just had to look it up. I was like, I don't know for sure what this even is. So I just, if anyone wants,
our
I
experience
just found
too.
the site. So I just kind of read through it. I was like, oh, this all sounds familiar. I think I read some of those papers, but I never learned those terms. I'm not a psychologist. I'm not even an educational researcher by background. I am a bench trained biologist as my background. So I am learning all of this biology education research as I go. And I'm a full-time professor. So I haven't had the time. So I would say the reason that I've chosen to go with self-efficacy and motivation, some of that is because that's what I saw being talked about at the education research conferences I was going to, particularly the SABRE conference. So I would just argue that just comment that I think it sounds great. Like when I read over them, I'm like, yes, we should do more of this. So I think it's, I will continue to try and incorporate it and in further iterations of this research as we go. And I think it's really important to include this because I didn't even know about it when I started the research project. So thank you for reminding me of this. I'm actually going to save this and send it to my team. So
It was actually an educational researcher that kind of brought this theory to us and, you know, laid it down at our feet and was like, it's this is what you guys should be looking. We're like, I still don't get it. I'm still struggling to understand like how this is going to impact decision-making or how there's been a lot of research built on this. But I'm intrigued that almost by osmosis, a lot of people, I guess, are considering this particular theory in educational research. And then we, you know, as educators are starting to use that terminology more. But I'm pretty sure that they're very embedded in this SCCT thing that I hadn't heard about until 3 years ago. But I feel like that's where they're all kind of like held together. And there's this theory of change or decision making related to those variables. But yeah, cool.
I have this feeling we could spend all day discussing these ideas and learning about your work, Goli, and Kristen's work. But I know it's the end of the hour, and I know a lot of you have other things to go to. I will be posting the talk. In fact, I'm going to stop the recording.